Howdy folks, got a Westinghouse fridge troubleshooting job here. This one belongs to a gentleman who was unable to get service on it in his hometown, so it was shipped in here. It's very nice, very deluxe I think. Condition is good, other than a few little issues, but nothing terrible. Everything is as it should be. I believe that's a frost level indicator. When the frost gets deep enough to cover that up, you're supposed to defrost it. The chiller drawer here, some spare parts in there. Have the two humid drawer hydrator bins, and they have the Westinghouse logo in the glass on both sides. It's a miracle we still have that glass, because all of this had tumbled in here. Normally, you know, we advise people to take all the interior stuff out before they're shipped, but that apparently didn't get communicated. So this glass cover was over here and this was upside down, but miraculously it didn't get broken. So that aside, all I've been told about this is that it doesn't work, and he had somebody work on it, I think, for a short period of time. They made some attempts on it and then gave up and just said that they can't fix it. And then he's been trying to get other people to look at it, other shops to look at it, and nobody has been willing to. As you can see, the cord is completely gone there. But these shops, they've all been crying environmental, nonsense is why they're not going to look at this, which is really sad. If you're worried about energy use, these use a lot less energy than most current production fridges, because they're a lot simpler. And if you're worried about the Freon, well, all of us who do this work have been trained on how to recover and not release Freon into the air. So all of that environmental nonsense about these antique fridges is really a moot point. And anyone who claims that's their reason for not wanting to work on it, they just don't want to work on it because they don't want to. That's a cop-out. So it's been shipped across country, and we're going to get to the bottom of the problem and get it working. The first thing I'm going to do is take this condenser loose from the back of the cabinet. It's obviously been off before. You look on this side, and that's the heat exchanger line clamped, between the body of the cabinet and the condenser. That's obviously not right, and I just need to see what's happening back in there with the cord. See if I can cut it back and get a little bit of good cord where we can make a test run, or attempted test run. Well, I found botulism. That's all cut off. Power cord is cut off. Hopefully that doesn't mean that they've done something to the compressor and damaged it. But as you've seen me do with other units, I'm going to go get a temporary start device and some alligator clip leads. We'll hook up to this and see if the compressor will run. But that's just terrible. All that was just left laying down in there. Now obviously when I see this, I'm not going to plug it in and just try to run it, but had the cord not been in such bad shape, I would have first taken resistance measurements and probably found an open circuit because of that. But that's the kind of thing that's really unsafe, and they should, if they're going to leave this all disconnected, they should have removed the power cord, or at least made it obvious that it shouldn't be plugged in. So this is a sign of a truly incompetent person. So the first thing I'm going to do to determine, viability of the compressor, I'm going to check the resistance of the motor winding. And the way this Westinghouse is built is awkward, but I want to try to get the meter on camera. Now that I got the meter on screen, we're going to check the resistance of the compressor motor. Now we know that the common wire goes through the circuit breaker, and that round thing right there, that's obviously a motor overload circuit breaker. So I'm going to take for granted that middle terminal is the common. I'm going to check to this lower wire. Make sure I'm not blocking the view there. Got 20 ohms, to the upper wire. Get a good contact. We got 3 ohms. Then between these two, it should be somewhere around 23. So that's good. Those resistance readings look correct. And then the last thing I'll do is I'll check to ground. And I don't see any continuity to ground, so it's not likely to be a burned out compressor. So the next thing to do is take a temporary start device. We've got a RO41 that is going to allow me to attempt to start this compressor up. And the RO41 has its own circuit breaker in it, so I don't need this in the circuit. And that old breaker is highly suspect, so I'm going to try to clip the clip lead on the wire in such a manner that it's not going through the original overload breaker. Just because I think it's a high likelihood that breaker is probably no good. And then we determined that run was the top terminal. So precariously attach a clip lead there, and then the start was the lower one right there. I don't think anything's shorted out or grounded. So you can see the switch box display there on the kilowatt meter. I have the cord plugged in. Check again, I don't think anything's shorted out. So unrehearsed, this is a start attempt. .4 amps and she's running. Doesn't even sound all that bad. It's allowed 3.2 amps according to the nameplate. And it's very cool in here this morning. We're having an unseasonably cold weather snap, so expect low current demand once it warms up, especially. This one has a neat spring-loaded door stop down there. Only trouble with it, it's very effective. It'll really slam the door if you're not careful. I hear something. And I even see frost on one of the lines back there. Oh yeah, that's definitely cooling. This room is cool, so it's going to be hard to see frost build up on it because the cold weather kind of takes the moisture out of the air. But I'm going to give it some run time and we'll see if it gets a full frost on there or not. But it sure sounds good. So we got a full frost all the way to the return line. If I turn the control all the way to the coldest, it finally would have clicked on there. So it's the temperature of the evaporator is almost to the full cold for this control. And that does tell me that the thermostat bellows is working. Now Westinghouse is unique in this era in that this thermostat is a unitized thermostat and motor start relay. So the fact that the compressor wouldn't run, probably the problem is right behind here, or some wiring. So now that I've seen that it's working, fully cold, you can kind of see some frost crystals growing off the edge of that. I'll go ahead and shut it down and start trying to get access to that thermostat. Nice splash lubricated Westinghouse. 2.4 amp, 159 watts. The condenser's warm all the way from the top to the bottom. I'm going to go for a shutdown. Awesome. That's a happy finding for me. When I saw that wiring cut off right there, I was thinking, oh man, they've probably damaged it, somehow burned it up, but no. It's still totally healthy. I think I found one of my all-time favorite serviceability designs. By taking the butter conditioner out, you have access in here, and I was able to take the thermostat control out through this opening. And the reason that's very significant, on these 40s and 50s fridges, this plastic trim around here is really difficult to remove and install, and it's super easy to break. So that design, it prevented me from having to remove both these sides and this top breaker strip trim with the risk of cracking them. So thermostat will go back in through there, push it in, move to the side, and pull it up where the knob fits right through there. And then in the back, the sensing line and cable from the thermostat go through the insulation. Sensing line goes through that rubber bushing to attach the evaporator, and then all the cables were junctioned right here. That's the back of the cabinet light and the cabinet light switch. So all the junctions were available right behind this black cover on the back. So yeah, a lot of this one's definitely got a lot going for it from a design standpoint. So I got this Westinghouse control out of the cabinet, and the power cable, the internal wiring in the cabinet where it was protected, you know, is still very flexible, but of course it's getting replaced. To make this easier to handle, I'm going to just cut it off, get rid of it, bend it. One thing I did have to do, they had soldered a bracket onto the sensing bulb here. The only way I could get that off out of the cabinet was to cut off the bracket. So I'll put a different bracket that's clamped on for reassembly, but that tells me this is the original thermostat. It's probably never been out before. One thing I noticed, what do you not hear? Listen. I don't hear a start relay armature moving around when I shake it. So that tells me right there pretty much all I need to know about why the butcher's got a hold of the compressor wiring. It was probably not starting with this start relay because the relay stuck, and they were too dumb to try to look up a manual for the machine to understand how it's supposed to work. And so they just figured it was a compressor. Told the owner that the compressor's bad. Typical for what you see with a lot of these lower level repair businesses that don't really care about antique and vintage stuff. All they care about is, you know, making $1 quick as possible. They don't care about, you know, saving anything that we consider important. So that is the thermostat contact. That's what switches the whole thing on and off. When that little round disc right there touches those 2 points, it's on. When it's down like that, it's off. So that's how the thermostat works. But this start relay is where I think the problem is. As you remember, when I had the compressor running hot wired and it was cold in the evaporator, I could turn the knob down and I could hear the thermostat click on and off, and not right at the beginning where off and on is. I mean, it had to go all the way cold before it would click off. So pretty sure the thermostat itself is working. It's just that we're not getting that pulse of current to the start winding. And you notice how this is rusted on the inside. That happens due to moisture. And the reason moisture builds up in there is because people have allowed the fridge to be operating in cold, and they've shut it off and left the door closed on the fridge cabinet. So that moisture stayed trapped in there without it being refrigerated anymore. So it was just free humidity. It got up in the insulation and did that to the start relay. So rebuilding this and rewiring it is probably all that was wrong with this ever. So had somebody local, you know, read our forums and watched our videos and done this repair, this thing wouldn't have to go across country, but it's neither here nor there at this point, because she's here, and I think we're also going to get it painted, so all's well that ends well. And just like on the last Westinghouse, the thermostat movable arm needs to be tied back with a cable tie, because if the start relay is taken out without the this tie in there, then that thermostat arm will flip all the way back, and a spring will go flying. And it can be reassembled if that happens, but it's just extra work. And of course, if the spring went somewhere I can't find it, then I got problems. I come in here with a pair of retaining ring pliers and use them to spread the body of the thermostat apart. And that should release that start relay. You can see the moisture damage in there is pretty bad. That little disc is supposed to turn freely as well, and it doesn't, so there's a tiny spring underneath it. It's all gummed up. So this is going in the ultrasonic. I'm going to put that in there to let it start working now, and then we'll come back and look at this mess right here. Probably hear the ultrasonic going in the background. So that little disc in there is pulled up magnetically by this coil during starting, and it bridges these 2 points together to actuate the start winding. But it's gone totally solid. The last one of these like this, I had to drill a little hole in the center of that and drive it out with a punch and hammer. But the first thing to do is to take these 2 rivets out and get the contacts out of the way so that thing can actually come out of there. So I'm going to go use the Dremel and a little cutting wheel and grind the heads off of them to start the repair process for this. Alright, rivets are gone. Take these start contacts off. This one's soldered into the series coil. This is the common input. So that one probably, I'm just going to leave it hanging like that rather than worry about desoldering and resoldering. And now see if this will pull out of there. Nope, it won't. Rather than break the plunger or something in there, I'm going to do like I did the last one, drill a little bitty hole in the center of that where a hammer and punch can be used. Okay, got a little hole drilled in there. That's got plenty of room to give it room to slide out before it hits the table. A little PB blaster never hurts. Didn't push out by hand, so I'm going to tap it. Boy, that thing is very, very stuck. I don't want to end up cracking the housing, so I got to be real careful trying to get it out of there. I'll let that penetrate for a while. Well, the first punch bent, so I'm going to go with a bigger punch. It moved. There's more clearance now. Well, it's almost out, but not quite. It felt like it completely was loose, but I guess not. Come on. Wow, finally. No wonder that wouldn't work. You think a little magnetic coil is going to move that when it's stuck where a hammer barely gets it out? Go ahead and get this part cleaned up. Got the parts all cleaned up for the start relay. Bore was honed out with Scotch-Brite, so there's no buildup from the old rusted armature. Armature has been polished down and has a rust-proof coating on it. Now you can see, operates by gravity, just like it should. Top surface of the disc is clean, contact points are clean. Put all the parts back together and well, hopefully it's going to work. I had to destroy those rivets to get them out, so I'm going to go back with some little screws. These are number 4. They're kind of fiddly to get in there. May not be able to do this on camera, but I'm going to try. You know, the factory puts things together with rivets and clips because it's easy for them to mass produce it. But when you're doing this kind of work to restore and rebuild things, it makes the job more difficult. But the stuff that they sell today, a lot of it is truly unrestorable. There's no way, no access to any of the working parts in it. Everything has to be destroyed to get it apart, if you can get it apart at all. It's a real sad state when you can't get parts anymore. The manufacturer basically just says, okay, we're going to stop supporting this, stop selling parts, and now all the poor saps who bought one of these, they got to buy another one. So that one is in and almost tightened. The other contact goes in there like so. That one not being attached, I can put the screw through first. Probably make it a little easier. Like that. Sometimes these are hard to get started. I think I got it. Have to come from the side with the screwdriver to get those tightened down. Now, to make sure this doesn't work apart over time, I like to put a little bit of solder on there too. So I'm going to solder those screws on. Well, there it is. Ready to go back to work. Got those soldered in. Like I said, if they back out, there's safety concerns. So I want to make sure that we've had a rivet that can't back out from the factory, and I want to go back with a soldered nut and bolt so we're equally secure there. So now go see if the rest of the thermostat's clean enough in the ultrasonic and go back together with it all. Got the thermostat cleaned up. It's clean as good as it's going to get. There's still a little rust in there, but that's not on a moving part, so I'm not worried about it. I'm going to take a little bit of this oil and I'm going to put a little drop on each of the pivot points in there. Help it not wear, you know. Although it doesn't look like there's any wear to begin with. Everywhere there's two parts that ride on each other or turn or slide, I want it lubricated. Of course, the goal is to lubricate only the moving parts, not the electrical parts. But I don't have the relay back in there yet, so we don't have both halves of the contacts. Sorry about that. So when the start relay, this little pad moves up and touches it, closes the contacts, that's what makes it run. So now for the really fiddly part, I'm going to try to put the relay back in there. This is the part that's totally a pain. Probably the reason that back in the day Westinghouse would say that this is a throwaway part, not to try to repair it. But like I've said before, they had that luxury back then. We don't have that luxury now. If you can't rebuild it now, you just don't have one. Have to adapt something else, and then you end up with something that doesn't work or sound exactly like it used to. This is where the three-arm genie comes in. Put this back together. There's just no easy way about it. Try to use these retaining ring pliers again to spread the housing. Trouble is, those insulation pieces are so wide, they take up all the space where you could spread it with the pliers. This top piece is not exactly where I want it. So that's pretty well locked in. Now the bottom one has to be manipulated into place. I believe that's it. So now the cable tie can come off, because the start relay is in there to block the thermostat arm from coming back too far. Let's see here. Had to go clear some space on the memory card, but this is all back together. Has the rattle it's supposed to have. Then they provided this little isolation piece to go in there, help give it some isolation between the live electrics and the chassis. Slide all this back together. It just squeezes in on the sides so that those tabs are sunk in a little bit, and then presses like that until these side tier tabs lock in. That's it. And of course it's labeled on there top, so it's got to be mounted like so. Works nicely. Now go slide it back in the cabinet. Well, I had to cry, Uncle. I got the big heater out. Just too cold today. So the control is in, the cable's in place. Got the compressor laid out here. I pressure washed the compressor only and then put some rust treatment on it. I'm going to give it a good coating of black paint to preserve it since it was rusting in there. And then put the new overload breaker on. That's the old one. I went ahead and got it wet washing it, so I knew it was bad anyway. It looks nice, but I wouldn't trust it. I think probably when the start relay stopped working, the compressor would try to start and it just tripped this overload over and over and over and over again because it couldn't start. And it might be badly worn in there, so again, I don't trust it. It's a cheap part, less than 20 bucks, so I'm going to put a fresh one on. A bit better to be safe than sorry. Well, now the rust will be kept at bay for a while. Put the shiny back on it. Now before the paint dries, I'm going to get these protective caps off the terminals so they don't get glued on there by paint. I mean, it goes without saying you don't want the electrical terminals to have a coating of paint on them. So we'll get them off of there before that dries. And then let it dry there in the heater for a while. Alright, got the Westinghouse rewired and all hooked up. Covers are still off so we can check it out. The new compressor motor cable goes down here. Ties onto the terminals back there. Brand new overload breaker. Grounded system now. We have a new power lead here. Goes through the original grommet. Comes up here to the back where everything was junctioned off. And I used the original Westinghouse 2-post junction block. It's all labeled. This is the interconnection between the start relay and the compressor for the start and run winding. Then we got the cord grounded and a bonding jumper for the outer shell and the liner, so we're sure everything is properly grounded. The light wiring was still nice and flexible, so I did put heat shrink on it just to double protect it. All that's covered up, so everything's double insulated. And going to make some electrical checks on it right now with the meter. So the door is closed and the thermostat is turned off. And what that means is there should be no continuity on the plug. So you can see the meter there on resistance mode. I take the new power cord. I'm going to check from one of the power input pins to the other one. And you see it shows on the meter OL, which means there's no connection, which is good because the thermostat's off and the door's closed, so the light's off. Next thing I'm going to do is check from both of the power pins to ground. So I've got no continuity, there's no ground fault. Now I'm going to go from the grounding pin on here and check to ground. And it shows a solid connection. So that tells me that there's no shorts in the system. So the next thing I'm going to do is open the door on the cabinet. So with the cabinet door open, the light circuit should be closed. I should be able to see the resistance of the light bulb. So again, I'm going from one power pin to the other on the cord. That looks like kind of a high resistance, so the light bulb might not be tight enough. I gave the bulb another little twist of confidence. Let's see if that gave us a lower resistance here. No, that's showing mega ohms. I think maybe the light circuit's not working, but that's not going to hurt anything to try to run the machine like that. So the next thing I'm going to do is go turn the thermostat on. So now I've got the thermostat in the on position, and I'm going to measure from one pin to the other. Now we should have a very low resistance. See, 3.6 ohms? That's because we're seeing the resistance of the compressor motor, which is, you know, a copper winding in the motor, so there's very little resistance to it. So I turned off the thermostat. So I've plugged it into the switch box. I'm measuring current. I'm going to turn on the switch here. Oh, we got some current flow. Apparently the light bulb decided to start working. I wonder if that's an LED light bulb. I didn't really look at it that close. If it's LED, it won't have much of a resistance measurement, but when it's powered on, it'll work. So apparently the light bulb's working. Let me close the door and see if that current draw goes away. And the light is on. Okay, the door's closed. There's no current draw. So it looks like that was just the light bulb. Let's go around here and try for a compressor start using its own built-in start relay. As you can see, the light's working there. So we don't have a cold control, we have a colder control. So let's see what happens. It's running. .8 amps. So the start relay obviously worked properly. I hear gas blowing through there, which is good. I'm fixing to turn it back off because I don't have the thermostat sensing probe where it's supposed to be. I want to get all that put together. So one test that you got to do on these to check out that this overload breaker is working is a stall test. I'm fixing to power it right back on. Well, it started again. And we'll let it build up some more pressure and we'll do that again. I want it to fail to start and I want to see that that overload breaker trips in what I think is the right amount of time. So I'm going to stop it. We'll attempt another start. See, it tripped. Now it ought to sit here and wait for several moments. And then once it's cooled, the circuit breaker's cooled off, it'll make another start attempt by itself. This is what would happen if there were a power blink and the power went off and came right back on. Or if someone turned the control off and right back on. But you have to be sure that that function is working. It may seem stressful and people don't like to see this, but it's got to be tested because I can intervene and turn this off on the switch if I think it's not tripping like it should. But if I send it on home and I haven't tested it, then it could be a disaster. So during this time, the overload breaker is cooling off and resetting, and the pressure is equalizing in the system. One thing I like about the Supco overloads, they have a long reset time. Gives the motor plenty of time to recover and cool off from that, there it started, from that first failed start attempt. So, stall test is successful. That's one more check in the book and go for a shutdown. I'm going to go ahead and try and tidy up the wiring. Well, I've set the compressor back in there. Got the wiring tucked in where it's supposed to be. The reason I haven't put this cover back on, this is probably going to get sent off for paint, and if that's the case, I'll need to be able to set the compressor back on here because the painter is going to want to paint the back of the cabinet. If the whole compressor thing is set back here, he can do that a lot easily and less costly than if all this has to be taped off. So till we hear definitive one way or the other, that's going to stay off of there. I put all the trays and stuff back in. Turn off my recording light. You can see how the light is diffused by the back of that drawer. Nothing shines in your face. Coming back on with the recording light. The thermostat probe is back in place back there. Go for another start. That's a nice quiet machine. Now what I don't want to do is let it run and get too cold without this insulation, because that'll make this whole back thing start sweating and collecting moisture, and then of course that would not be good for the insulation. So for today I'm going to call this a video, and hopefully y'all appreciate seeing this Westinghouse get fixed up, finding the unsafe prior repair attempt, and finding the real problem and getting it fixed. Thanks for watching.